Alright guys, this will be a quick lesson. We're going to just get started with 12. 1. We're still going to be talking about circles. We're going to try to get through 12 and 13 together real quick. We got inscribed and circumscribed triangles and quadrilaterals. So we're going to define what inscribed and what circumscribed is. It's not what you think. That's for babies, and we're not talking about that. Alright, so inscribed polygon is a polygon drawn inside a circle such that each vertex of the polygon touches the circle. So here's a vertex, 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 and vertex. You can see all of those vertex touch the circle. And it's so inscribed kind of inside the circle. Notice the polygon is inside of the circle. So inscribed right triangle diameter theorem says if a triangle is inscribed in a circle such that one of the sides of the triangle is a diameter. There's our diameter. Then the triangles are right. So I know right here this is going to be a right based on this theorem right here. So I automatically know that is a right triangle because I know this is a diameter because it goes through the center of the circle, which is A, and it goes to the end of the circle here, and it goes over to this end of the circle here. So that's that. Alright, another theorem, inscribed right triangle diameter converse theorem says, hey, if I know that it is a right triangle, notice I know it's a right triangle this time, then I know that this has to be a diameter. So the other one said, this is a diameter, then this must be a right. This one says, if it's a right triangle, you know this has to be a diameter. That's the converse, remember, when you switch the if and the then. Alright, now we're getting to that other word, the circumscribed. Alright, so a circumscribed polygon is a polygon drawn outside the circle such that each side of the polygon is tangent to the circle. Remember, tangent is a word that we talked about. Notice it only hits the circle at one point. I'm drawing all the tangent points right there. So this would be a circumscribed. Notice the circle is on the inside of the polygon, whereas last time when it was inscribed, the polygon was inside. So that's going to be the difference between inscribed and circumscribed. And again, we're just breaking these vocab words in. We're going to use them probably more throughout this chapter. So inscribed quadrilateral, opposite angle theorem states if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. Supplementary means they add 280 degrees. So this right here is opposite of this. And these guys together will add to be 180 degrees. These guys right here are opposite each other, and they will add to be 180 degrees. That's what this theorem is stating. Alright, this is in page 920. Consider this quadrilateral WXYZ, which is circumscribed, which means the circle is inside of the quadrilateral. And we know that from here to here is, and from here to here, when I add those, it equals 23. Alright, well, we know some stuff from before. When we know if this is, since this is circumscribed, I know that this line is tangent. I know this line is tangent. This line is tangent. I know this line is tangent. Because of tangency, I know a tangency exterior point theorem that talks about, hey, from here, from A, which is the point of tangency, to W, that length is the same as from D to W. So I know those are congruent. And it went through and they marked all the parts that are congruent based on that theorem. I know these are congruent. If I look at this, and I look at WX, it's really equal to a 1 tick mark and a 2 tick mark. So W to X is a 1 and a 2 tick mark. And if I look at this one, it is made up, YZ is made up of a 3 tick mark and a 4 tick mark. Well, when I go to this one right here, because I'm going to want to, they asked me for the perimeter, which is all of those sides added together. So they're asking me for that. When I look at YX, it is a 3 tick mark plus a 2 tick mark. But notice right here, for this part right here and this part right here, I have a 1, 2, and 3, and a 4 added together. Those lengths, whatever they are, they're unknowns, but I know that I have a 1 tick mark, a 2 tick mark, a 3 tick mark, and a 4 tick mark. Well, so far, if I add this side in, I get another 3, I get another 2. Well, when I add WZ in, I get a 1 and a 4 tick mark. Notice I have 2 1s, 2 4s, 2 2s, and 2 3s. So essentially, if this plus this is 23, I know that this and this is going to make another 23 because they're using the same numbers over again, right? Not 1, 2, and 3 necessarily, but whatever those numbers were, I'm using them. So I'm going to have 23 plus 23, so I'm going to get that my answer is 46 centimeters would be my perimeter. That's just an example of how we can use some of the theorems from the old stuff, and we're just talking about a circumscribed, but I didn't even use the theorem from this one. I used my theorem from the old about tangency and a point exterior of the circle. So that was actually from chapter 11 that I used for that. Hope you have a good night, guys. We'll practice this again. Make sure you study for that test night. Have a good Monday.